Introduction. What's the problem that we're trying to solve? Adaptive streaming is great. It actually makes it possible to stream video over internet and for half of this room to have a job. And the problem with it, not with a job, with adaptive streaming, is that we need to encode a lot of times the same content. So how do we make it faster? And in this talk, we'll try to hand wave through how we can make it faster by recycling analysis decision. How is this actually done for HEVC, and how can you use it now with the X265 open source codec? So the motivation, okay, the same problem, a lot of encodes. In case of Apple HLS, you have 12 encodes that you actually need to do to provide Ultra HD content. And this requires a significant amount of computation. And there is a glaring inefficiency here, because the content is perceptually identical. If I'm moving my hand, those of you who are viewing it on live stream, you will view exactly the same hand. The only difference is how many pixels does it occupy. Now, if we formalize this, we have identical motion field, identical objects, identical texture. The only difference is resolution or the bitrate. Now, this means that you have very high correlation between motion vectors and quadtree structure on one resolution and on the other. But, and this still amazes me, in a lot of cases, we're trying to solve exactly the same problem and find exactly where my hand is 12 times. So the solution is very simple, and that's why it's a 10-minute talk. Just take encoder decisions and reuse them. So let's define analysis information. Mainly, this is motion vectors and quadtree structure, but also other data. And we run a low-resolution encode, 540p, for instance, in this example. We export it, and then we reuse it at higher resolution. So in the X265 implementation, it's 2n by 2n. So 1080p in this case. We go and scale it, and then do some amount of refinement. I'll talk about it in a couple of seconds. And then we go and reuse it, and we reuse it in the bit stream. We export the new